functions. We're going to take this up a notch, okay? We were dealing with quadratics, and now we got to move on. You got to have your handy-dandy calculator. So that means I have to have my handy-dandy calculator. Lindsay, will you? You're going to, where is it? There it is. There it is. Let me move that here. Let me move that here. Let me move that here. Nope, not here. Okay. Yeah, if you want. Okay. All right, so here we go. Functions, folks. Shh, listen. Psst. Here we go. I'm thinking we have a birthday today. Do we have a birthday today? Happy. Oh, big dog. Big horse. All righty. Here we go. In behaviors, folks, a little bit different from what we've been thinking about. This is literally describing the movement of the curve. Okay? Now, it's not like the movement this way, but it's kind of the way the curve goes. So I'm going to call it the movement. The x value of the vertex helps us here, okay? It helps us determine where the parabola turns, because think about it. If you have a parabola, there is a moment in time, especially if it's either way, if it's an upward-facing, upward-turned parabola, there's a moment in time where, for a split second, it turns upwards. Do you agree? It's one moment, one particular point. The same thing happens if it's a downward. For one split second, it's that moment where it turns. So that's what we're looking at. And it's a vertex either way. So we've got to pay very close attention to the x value in the vertex, okay? We describe the behavior of whatever the curve is of the graph f of x, folks. The f of x is the curve. As x approaches positive or negative infinity. And then we must describe that interval at which it is increasing or decreasing. All right, that's all well and good. Got to give you a little bit of information before we see how this works. Okay? So we're going to look at the curve, how it approaches, how x approaches positive or negative infinity, okay? Are we ready? Moving on. Look at this next. And I've got highlighters back there if you want to use a highlighter. But we're going to look at this curve, x squared minus 4x plus 3. Clearly, it's what kind of a function? Is it a linear, quadratic, cubic, quartic? It's a quadratic. How do you know it's a quadratic? Looking at the equation, how do you know it's a quadratic? It's got the squared term, okay? So we know that it's a quadratic function. And then I highlighted it has a restricted domain. What the world? Why is it restricted? Because it ends with points. It doesn't have arrows on the ends. Do you guys agree with that? That should make sense. It makes complete common sense to me, even if I didn't know what it meant. If I didn't know anything about parabolas or domain or range, I would get that it's restricted because it ends. It has points, kind of like a segment versus a line, right? But it says that the domain has been restricted. We've got to identify the domain and range. We know how to do that. And we've got to look at the intervals of increase and decrease. This has to do with end behavior. And our book's not really good about this, and we're trying to pull all this stuff from all these different places, so you'll be prepared when you get to that SOL. We may be giving you too much information, but it's better to have too much than not enough, okay? So look at this figure. Look at this curve, this function, this parabola. It says this graph shows only part of the graph f of x is equal to x squared minus 4x plus 3 because it has a restricted domain. The domain includes all of the x values. Do you guys agree with that? We know that already. The least x value, and folks, this is what I'm telling you. You may have to draw some little notes here, but if I don't do this myself, I'm going to make a careless mistake, and I'm going to pull the wrong number. Okay, and I don't want to do that. I don't want to make careless mistakes. When I know where the x values are, they're on my horizontal axis. The least x value on that curve is 0. Do you guys see that? How do you know that? Well, if I had to plot this point right here, what would the ordered pair be? 0, 3. So that's the least x value that we're looking at. The greatest x value then is what? All right, now, why did I do this? Because I need to physically see where my x's go from left to right. My greatest x value is, of course, 4. If you needed to plot that point, then you would plot that ordered pair 4, 3. Do you guys agree with that? Okay, making sense so far? All right, so if my least x value is 0 and my greatest x value is 4, what is my domain? Well, we're going to fill the blank with a 4. So 0 is less than or equal to x, which is less than or equal to 4. Do you guys agree with that? Hands up, yes or no? Got it. Okay, high five. The range includes all of the y values, right? All of the y values. Or the f of x values. The least f of x value. Okay, now here, again, now you guys know me well enough to know what am I going to have to do to my graph. I better draw a vertical line with my y's, all right? Because if I don't, I'm going to make a careless mistake, and I can't stand careless mistakes. Now, what's my least y value? How come? Use the word that you see on your calculator. Okay, what is it?
Minimum.
It's the minimum value. That's my vertex right there. What is that ordered pair, folks? 2, -1. And what did I do yesterday? You saw me do it. I circled my y because if I don't, I'm going to make a careless mistake. That's called paranoid. I hate careless mistakes. So my least f of x value is -1. And the greatest value is, do you guys agree with that? Yeah? Everybody cool? All right, we'll keep looking. So the range is going to be, what will I put in this blank? -1 is less than or equal to y, which is less than or equal to 3. Right on? Excellent. The axis, Yeah, because it has dots. It has a clear beginning and it has a clear end. Yeah, good question. Yes? If it were a discontinuous function, yes, but we're not there yet. Okay? I could give you a parabola that would look like this. It could have a hole in it, and that value could not be included in our domain or range, okay? So, but we're not there yet. That's something out there, okay? Just be prepared. Give you a preview. Now, domain and range, everybody good with those? Everybody's fine with those. Let's look at the next one. It says the axis of symmetry that divides the graph into intervals of increase and decrease is x equals 2, the axis of symmetry. We've not really talked about that, but I want you to make some assumptions, make some relationships, figure these out here. Where'd they get the x equals 2 from? The axis of symmetry. X equals 2. Where it crosses the x-axis, but it crosses the x-axis at 1 and 3. Ooh, but the vertex. What does the vertex do? What is the axis of symmetry? What could we do? Splits it straight down the middle, so if we were able to fold it like a sheet of paper and open it up. Remember doing those ink things on paper when we were little? Did y'all ever do those? You like pour ink or paint on one side of the paper, you fold it over, and when you open it up, you get that. It's teaching you some symmetry, whether we realized it then or not. Y'all have never done that? No way. You've never done that? We should. Every single parabola has a line of symmetry, and it's going to pass through what? The vertex. So, folks, there is an imaginary line. I probably ought to do that in red. That passes through that vertex, and a vertical line is going to be of the equation x equals a number, okay? And look at my x value in my vertex. Isn't it 2? Right? That's going to be helpful to us. Very helpful. Axis of symmetry, we think vertex. All right? Now, let's keep looking at this. So if you look at your picture, folks, and remember we're looking at functions like we're reading a book from left to right, it says the function is decreasing on the interval from x equals 0 to x equals blank. The function is decreasing, in all my lines, from, let me erase this so you can see it. Okay, I'm going to draw my axis of symmetry in there again. But my function is decreasing from 0 to what x value? To what x value? What's the vertex, y'all? To -1, right? So my x value in the vertex is 2. 2, 2. There's 2. Look at, you got to think x's. We have to think x's, okay? This function is decreasing from this point right here, 0, 0, right? Actually 0, 3, because that's the highest point on the graph, right? From 0 to 2, it's decreasing. You with me? Yes, because we're looking at it like we're reading a book from left to right. Left to right. And then in that moment in time, what happens once it reaches x equals 2? It starts going back the other way, and it's what? Is it decreasing still or increasing now? It's increasing from what to what? 2 to 4. How did you get that 4? Because that's this point up here. 4, 3. Pardon me? That's the movement I was talking about. When we're actually looking at the curve, how it moves. Now, it's a whole lot more, it's a lot less difficult to figure the end behavior of parabolas because, do y'all remember that function we looked at yesterday that was a W? Remember that one? Oh, my Lord, have mercy. Decreasing, increasing, decreasing, increasing. I mean, it could go on and on. Okay? But be prepared for that. Does that kind of sort of make sense? It should. It's just looking. Now, where are your careless mistakes going to come in? Because when we're talking about what the interval is from increasing and decreasing, what do you think where are you going to make I'm not going to speak that on you. Where might someone make careless mistakes? Using the y value and not the x value. So I'm telling you, you better do something to do, x out your x values and put a line under your y value. I don't know. I don't want you to make careless mistakes by grabbing the wrong value out of your ordered pairs. Okay? Let's fill in the blanks. Any questions thus far? Fill in the blanks. The domain of this function is 0 is less than or equal to x is less than or equal to. Domain has to do with x's, correct? And is it going to stop at 4? We had it up here anyway. So it is going to be at 4. Its range is what to what? Psst. I'm sorry, -1 to 3? Yeah? How'd you get that -1? It says it up here. But if you look at the graph, what's your y value in your vertex? -1. So, pardon me? Mm-hmm. On that graph. Uh-huh. Typically, we have looked at parabolas and their domain is always what? -infinity to +infinity. What makes this one different? Because it has a restricted domain. It has dots, not arrows. Okay? You guys understand that. I totally know you do. All right? The function is decreasing on the interval from 0 to what? 2. And it's increasing on the interval 2 to 4. Notice the signs, the symbols. Yep. That was my next question. Why is it less than 2? Why is what less than 2? Here? This one? Because that's where it turns. That's the x value of my vertex. Why can't 2 be included? Why? It is the vertex, but this interval includes this value twice, doesn't it? So it's that the only thing I can think of is because this number is shared by both the decreasing and the increasing interval, it can't be both. So it's going to we can't include that value. That's the only thing I know to tell you. Okay? If it's both places, then that's going to be a less than and not a less than or equal to. Okay? That's the only thing I can get from everything I'm reading. Because the 2's both places. It's that moment where it's both. It's not one or the either, or one or the other. It's both. It's part of the increasing and the decreasing. Okay? Guess because it's shared. It's the only thing I can think of. Other questions about this? Good. All righty, moving on then. So some of you are so enthralled by this, obviously I could give you this example and you would be fine figuring it out on your own. Pardon me? What do you usually have attached? Q, look at Q. Look at Q. How could you graph that Q? Total calculator problem. Calculator. Okay? Total calculator. Lindsay. Thank you. All right, so we've got x to the 4th minus 5. Where is it? There it is. X raised to the 4th minus 5. Y'all got that? Graph it. Ooh, that still looks like a what? It still looks like a parabola, but it does look different. Why does this parabola look different than our typical? It's kind of flat. Oh. How? No, I'll go there. Okay, it's flat, right? Okay, I'm going to go there. There we go. I don't care. All right, graph it. Now, where are we going to graph that flat bottom? Yes, on your yes, on our papers now. We're going to sketch that flat parabola. The flat parabola. That was good. That was good. Where does it cross the y-axis? Hey, how can we find out for sure? X equals 0. What is that value? Just -5? Okay. Flat on the paper. 1, 2, 3, 4, 5. And it's kind of flat. And where is it going to cross the x-axis? Looks between -1 and -2 and +1 and +2, doesn't it? Okay. That was so good. All right, look at all the things you got to find. You got to find the domain, the range, the y-intercept, the intervals of increase and decrease, and the end behavior. Okay. By us and folks, well, find everything up until end behavior. You can do that yourself. You don't need me to guide you through it because you're following exactly what you just did on the other example. So, what are we looking at? Domain. Remember that this domain is not restricted, and how do we know that? Because it's got arrows on it, okay? So if it goes on forever, never, 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 what's our domain, folks? -infinity to +infinity, okay? You asked, do you want us to list all the different ways to, or the range? I would put it every single time. I'm going to, on my own paper, I want you to be familiar with anything you could possibly see on that SOL. Folks, what is that vertex? Because the vertex is important to me. What, say it again? 0, -5. Okay? So my range has to do with y values. My range is what? The range is what? Here we go. Oh my. Will y be greater than or equal to -5? Yes or no? Okay. Oh my goodness gracious. If y is greater than or equal to -5, then that means it's going to start at -5, and then it goes to what? +infinity. And the other way I can write my range would be -5 less than or equal to y less than +infinity. How many of you have all three of those correct? All right, you got to get this. Got to get it. Then it said y-intercept. Well, what's your y-intercept? It equals -5. How many of you had that? Hands up. Good. All right. And then it talks about intervals of increase, okay? F of x increases. My curve increases. I want to go in the order of the curve, okay? So I'm not really going to talk about increasing first. I'm going to talk about decreases. My curve decreases from what to what? From -infinity to 0. Now, I'm trying to put it in interval notation, aren't I? All right, so let's change that. So -infinity is going to be less than x or y? X, very good. Which is going to be less than what value? 0. And I get that from my vertex's x value. Do you guys, how many of you have that? Hands up. Very good. It decreases, and at that moment, it starts increasing. So f of x increases from what to what? From 0 less than x less than positive infinity. Excellent, folks. Yes? Here. Remember from the last one? I think it's because it's shared by both the increasing and the decreasing interval. Can't touch infinity, ever. Okay? Questions? Other questions? Pardon me? Okay? Okay so far? All righty? Yeah. Uh-huh. Now, in behavior. Folks, look at the in behavior. It says the graph shows, and folks, this is just common sense. Both arms of this function point where? Up. That's all. That's all. Both arms point up. It says you could also determine this because the function has a blank degree. Look at the function. It was x to the fourth, wasn't it? Folks, remember finding degree in Algebra 1? The highest exponent is what kind of a number, even or odd? The highest exponent is even or odd. It's a 4, so that means it has even degree. Has an even degree, and its leading coefficient is 1, which means it's positive, and anytime your leading coefficient is positive, it's going to be upward turned. And if, I don't know why I put the blank there, just kind of mark it out, sorry. If it is a negative leading coefficient, then what's going to happen? If it's an even degree polynomial, it'll point down, okay? Positive leading coefficient points up, negative leading coefficient points down. And this is for even degree functions. Comprende? See? All right. Identify the intervals of increase and decrease. We've already done this. Just as with the quadratic function, there's a line that separates intervals, la, 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 la. Let's see, for this function, that line is the y-axis for this problem. Or, hey, what is the equation, the line that goes through the y-axis? X equals 0, which is just strange, but that's what it is. So the function is decreasing until it reaches x equals what? This is just going back to what we've already done. 0, then increases to positive infinity. We can write that the function's decreasing on the interval negative infinity less than x less than 0, and increasing on the interval, we've already written it, what is it? 0 less than x less than positive infinity. And this book has pretty brackets, so we'll put pretty brackets. Okay? Questions? Will you be able to do this on your own? Bullcrap. Yes, you can. Don't you shake your head no. Yes, you can. Yes, you can. Yes, you can. All right, let's look at another one. Questions at all? Identify the degree. We've already said it's an odd degree polynomial degree of 5. It's getting ready to write 4. Degree of 5. You know that from the exponent. Determine the domain and range. What if I made you, do you know how I would have had to do this back in the day? By hand with an XY graph. That was fun. You guys don't have to do that. Thank your lucky stars. Lindsay, if you'll cut the calculator on. All right, here we go. So, I'm going to have to look on your paper. Negative 2x to the 5th. Plus x to the 4th. Minus a plus x plus 7. I could, but then I can't see my recording thing, and anyway. Do I have that plugged in correctly? Don't let me make a careless mistake. It would be horrible to do this problem with a careless mistake. Negative 2x to the fifth plus x to the fourth is 4x squared plus x plus 7. I don't think. Let's see. Oh my. What the world? That is a weird looking line, isn't it? Yeah. Okay. Is that what you have? If you didn't, go back and make sure you put everything in correctly. Help each other, because this is, when it's 31 of y'all and one of me, it's easier for y'all to help each other than for me to come to each one of you. All right, now, this is what we were asking before. Yesterday we looked at that W, that function that looked like a W, and I told you, you may want to, at the top of the page, write this. If it's a even degree, let's put another page in here. Yeah, let's put this in here. If it's an even degree function, it's going to look like this, or this, or it's going to look like a W, or what other letter? An M. Or it could be a flat bottom parabola. You all need to YouTube that song later. Nope. Nope. But we looked at a, it's not funny. I don't know why I'm laughing. But we looked at a x to the fourth polynomial, and it was flat vertex, right? Okay. Why? Folks, if it's an even degree, it could be, if it were an x to the fourth plus x to the third plus blah, 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 that means it could have 4 real solutions or 2 reals plus 2 complex, or it could have 0 reals plus 4 complex. We always come back by 2's, okay? So it could have 4 real solutions, which means 4 x-intercepts, and that's why we had a x to the fourth, but it was a flat parabola, okay? The same rule of thumb is true for odd degree polynomial functions. Okay? Odd degrees, they're going to look like this. Or they might look like this. But one arm's up, one arm's down. Okay? Now that function that we just are getting ready to work on is an x to the fifth function, right? And I'm going to put plus dot, dot, dot. What does that mean? How many possible real solutions could it have? It could have, wait a minute, if it is the fifth degree, it could have 5 x-intercepts. It could. 5 real solutions. Or it could have what? 3 or 1. And then the rest of them are those complex. That means they're not going across. Because, you know, depending on where and you'll see this. You're going to know 1 arm up, 1 arm down, odd degree. 2 up, 2 down, even degree. Okay? So if your function looks like this, boom, John Travolta, is it even or odd? Odd. If it's this, what is it? Touchdown is a what? It's a what? Even. What we're doing, folks, we're describing the end behaviors of these functions by stating 1 arm up, 1 arm down. I'm not just making this stuff up. The even degree functions, both arms up. Or both arms down. Comprende? Yeah? All right. Does everybody have that? Okay. We've got this negative 2x to the fifth thing. Look at the picture. Look at the graph. Daggone it. Lindsay, cut it back on for me. I'm sorry. Glad you're sitting there. All right, so, folks, does this have a restricted domain and range? No, because it goes on forever and ever. Okay? Very, very, very facile. You ready for this? What's the domain going to be, guys? Infinity to infinity. Negative infinity to positive infinity. Because remember, nothing is restricted. It's going to go on forever and ever in both directions. How about your range then? Okay, now, I still want to go little number to big number. It's all the same, folks. It's all the same, okay? Still go little to big. I'm thinking number line. I still think number line. I still think it's got to go number line. It's not going to be wrong because what's another way to write this? All real numbers, okay? Absolutely, you may write that. Yes. It could be. It might be written out the set of all real numbers, okay? But you also may write it's still the same set of numbers no matter if it's positive infinity to negative infinity. I still think it needs to be smallest value to biggest value. All right, now, determine the end behavior. It says this polynomial function has an odd degree. Where does it cross? Oh, if you had to sketch this, what points on the graph are important to your sketch? 7 is where, Anna? Up on there. What's up on there? On the y-axis is a 7. You've already checked it?
Oh, well, I can't.
It's 7 point something, right? How could we find it? Second trace value. The value is going to be 0, isn't it? It is 7. Straight up 7. It's all right. It's still 7. It's a sketch. Okay? So y is 7, and what's our x value? Okay, I'm going to check the value just because that's the quickest way. Nope, it's not 1, but it's close to 1, isn't it? I could find the 0 if I wanted. And I'm going to go to the left. My spider's to the left. My spider's to the right of it. I don't want to guess. So it's a little over 1. Do you guys agree? So my y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. My x-intercept is a little over 1. And those are the only 2 points that are important to our sketch. And I got to look at it again. Okay. It's not. Okay. Is it something like that, y'all? Is that totally messed up? All right. That's why I wish I had my calculator in my hand so you could see a big calculator. It says the polynomial function has an odd degree, leading coefficient's -2, which is negative, of course. So the left arm points up and the right arm points down. You're not going to have your calculator taken away from you. So use it. Okay? Questions so far? Yep. This part? For right now, we just are sketching. For the interval, I would find, let's see, minimum. I would find the minimum value with that being my left bound, that being my right bound. Never had that question. Let's see. I would, if you wanted to be specific, then you would plot that point. Okay? Well, what would it be? Let's see, it would be, think about is this increasing or decreasing from left to right first? It's going to be decreasing from where? Let me go back here so I can write this down. Whoo, y'all are taking this like good day in the morning. We were decreasing, f of x decreases from negative infinity to, what was that x value? I don't remember what it was. Negative 0.8. Wow. Okay. All right, so it's decreasing from there to there. It's going to be increasing from where to where? Holy jeez. Say it again. Yes, there should be. Thank you. Thank you. Okay. Y'all with me? Wow. I don't think this is going to be on an SOL, but this is really good to make us tough. All right, now, f of x, the curve is increasing from where to where? It's going to be increasing from here to here, won't it? So negative 0.8, wow, to what value? 0, because we have to focus on the x values. Very good, Mariah. And then, all right, so we're decreasing, we're increasing, we're decreasing because that a girl. Pardon me? We found the minimum value by finding the min using the calculator. I went to the left of this one. I went to the left, put my spider here, put the spider to the right. This is really a problem on steroids, y'all. It's going a little bit farther than we need to go. It could be a little bit different. But this is, you're right. Okay, so let's go back and find it. So now we're going to find the max. Here we go. So I'm at the left of my maximum value. Holy crap. Now I'm to the right of it. All right, so it's actually 0.1, which is like a speck of sand away from 0. But we're going to put 0.1. 0.1. Because this was our max. This was our min. So now we're going to put what? Wow. 0.1. Less than x. X value, what's happening to the x value? It's getting bigger, bigger, so it's going to positive infinity. Look at you, farce people. High five, guys. Bam! I know. If I'd have fallen, would you laugh? Or I cry every day you leave because you hurt my feelings so badly. Then you'd laugh, right? I got you. That would not bode well. Questions at all, folks? I feel like I've run a marathon. Holy moly. All right, let's do another one. Go to the next one. Determine the end behavior and find the zeros and x-intercepts of the function. Folks, I also want you to find what? Domain and range. You can find the degree. Find a degree and a domain and range. Did we take the first one? Take the biggest one to find the degree. Aha. So what should we really do to this function? Rewrite it. And then put it in your calculator. Okay? What is the degree, by the way? 3, which is odd. You guys do the rest. Good Good job, publisher. That's called editors who don't know. Make that y-intercept, folks. All right, let's see. Lindsay. All right. X cubed minus 4x squared plus 4x. X cubed minus 4x squared plus 4x. Graph it. All right. Now, here we go. First thing, we got to graph it. Y'all got to help me because I guess I could move this. But it's going to go away as soon as I touch the board. Let's see here. Is it passing about 0 and then at 2? And was it something like this, maybe? Ooh, that's a bad sketch. Ugh. Give me your calculator. Let me sketch it from this. All right, so goes through there, touches there, and then here. Does that look better? A little better. It's a sketch. It's not going to be perfect. All right, so there's my graph. Let's talk domain and range to get that out of the way. Folks, this gets bigger and bigger both ways. So domain is what? Negative infinity to positive infinity or all reals. I don't care how you list it. Either way, it's correct. You have to be able to recognize it all the ways. Clearly, the range is what for this one? It's all reals, which is, for me, negative infinity to positive infinity. Because we've got to go little to big. Wide. Okay? Domain and range, how many of you got that correct? Hands up. Very good, guys. Very good. All right, so we got domain and range. We've talked about degree. Let's talk about end. How about the zeros? There are 2 real zeros, 2 real solutions in this, right? Okay? What are they? Our zeros are the set of, one more time, 0 and 2. And you just find the zeros. How many of you had 0 and 2? Good. Y-intercept is at 0. How many of you had that? Okay, see, y'all are more calculator ninjas than me. I'm not really a calculator ninja. We found the zeros. We found the intercept for the y. Let's see. We talked degree. We got to find end behavior, right? Nope. No, it isn't. Don't even speak that. End behavior. Here we go. All right, look at it from left to right. One arm down, one arm up. Do you guys agree with that? Okay. One arm down, one arm up. Now let's talk intervals. Okay. So it looks to me that it's increasing. So f of x increases from, bless you, negative infinity, 0.7. How many of you had that? Good. Then it's going to, very short amount of time, it's going to what? It's a little decrease from 0.7 to what? And then it's going to shoot back up. You guys agree with that? So then it's going to increase from 2 to positive infinity. Folks, that's not that bad. I was flipping out thinking, oh my God, that's not bad at all. That is complete. Now, can you fly through this? No, you really got to take your time and think about it, okay? Got to think about it. Now, here's what you're going to do for homework for me. That problem right there. The last problem in your notes, I want you to do this. You're going to describe the end behavior, the degree, the domain and range, and you're going to identify all of the intercepts. And looky, oh, it doesn't even have anything you can graph on a calculator, does it? Sometimes you're not going to be given an equation. Okay? That's your homework, folks. This right here. One problem, for real. One problem, y'all.